We're going to begin talking about algorithmic composition by introducing the score-gen construct in Nyquist. We've seen ordinary programs, unit generators, operators, and we've seen score-like programs using simultaneous to instantiate a bunch of notes at given times with given stretch factors. And we've seen scores, which is a more data-like representation of the instantiation of behaviors at starting times with stretch factors. These give us lots of choices. The point about Nyquist and its design is to try to make data and programs work together. So in Nyquist, programs can create data. You can generate scores. You can use timed seek to interpret scores and invoke functions. Programs can even create other programs, although we're not going to talk about that. And so there are no right or wrong answers for how to specify sound, whether to even use a score at all. If you do, where does it come from? But today we're going to look at programs creating scores. And I want to introduce a very powerful macro construct in the Nyquist system called score-gen. And this is designed to address the problem of creating a score full of notes or full of sound events. You do this with score-gen by specifying attribute values. You specify the values by writing SAL expressions that are evaluated once for each note. And the score-gen macro gives you a flexible way to express start time, inter-onset time, or duration, and also control the number of notes that you generate. The alternative to using score-gen is to build scores with list primitives. And, we've been there, done that in a project and in some of the lecture examples. It probably wasn't the most fun way or expedient way to generate scores. Let's look at score-gen. The basic form of score-gen looks like this. You write score-gen as if it's a function. It's actually technically not a function, but let's don't worry about that for now. The parameters look like attributes and expressions. And here's an example of a very simple score-gen expression. We write score-gen. We say the score length is going to be 2, so 2 notes. The pitch of each note is going to be 60. The velocity of each note is 100. The inter-onset interval is 0.7. And the name, in other words, the function that we call to realize each note, is just the simple note. And if we run that and turn it into sound, we get this. 2 notes, pitch 60, inter-onset interval 0.7. Pretty straightforward. Now, the power of score-gen comes from 2 things. First of all, there are lots of attributes that you can use. Some of them are special. They control how many notes, inter-onset, timing, duration. Other attributes just get passed in as parameters to the behavior that you're invoking with the score. I should recommend that you read up on score-gen in the reference manual for a full description. It's not something that you can just intuitively write down and remember how everything works. And also, I'll confess that the IDE is not very helpful in terms of suggesting what the parameter values are. Some of the attributes that you type into score-gen are not really used by score-gen, except they're passed on to the behavior. Okay, so let's look at what's built into score-gen. When score-gen is running, there are some special variables that you can access in expressions within score-gen. The first of these is sg:\start, and this is just a variable name. The colon doesn't mean anything special. It's just part of the name. sg:\start tells us the starting time for the current note that's being computed. sg:\ioi is the current inter-onset interval, and sg:\dur is the current duration. And finally, every time we compute a note, SG:count is incremented. So it's how many notes have been computed so far. So here's an example using SG:count. We write scoreGen. The length is going to be 10 notes. IOI is 0.2. And the pitch is going to be this expression, C4 plus SG:count. So that will generate a chromatic scale, C4 plus 0, C4 plus 1, and so on 10 times.